Welcome to the Department of Collegiate and Technical Education. I am Dr. Lakshmi Devamma, working in the Department of Mechanical Engineering. I'm going to start the second session of additive manufacturing. Subject code is 17ME82. Here in this session, let us discuss about the differences between additive manufacturing, CNC machining, that is in the concept of 3D printing, additive manufacturing process chain, and various systems like solid material system, liquid polymer system, discrete manufacturing system. Let's go one by one. 3D printing versus CNC machining, that is additive manufacturing and the CNC machining. Here the main difference between the 3D printing and the CNC machining is that 3D printing is a form of additive manufacturing, whereas CNC machining is a traditional or subtractive manufacturing here. That is, in the CNC machining, in actual practice, the CNC machining and additive manufacturing system both are same. Here, especially when it comes for utilization of the system, both the systems like the CNC machines and the additive manufacturing system also utilizes the computers. Both of them are computer controlled solutions to making products out of a given material. They are both machines at the forefront of building technology safely and efficiently. Here, which means that CNC machining starts with a block of material, say called it as blank, okay, and cuts away material to create the finished part. To do this, it needs cutters and spinning tools are used to shape the pieces in CNC. That is the reason I have told it is a subtractive machine where compared to additive manufacturing machines. Here in the CNC machines, the tooling and the maintenance of the tools, it adds a burden to the manufacturing cost, and also the accuracy depends on the skilled persons who is operating. That's the reason I told it is a traditional or subtractive manufacturing system. And another difference here is that we can build a prototype in the additive manufacturing as a part of customs product. They are turned to one of these machines to do the job for them. As long as the machines have the design, you don't have to worry about the human errors, because the machines are automated, and even in the CNC machines as well as in the additive manufacturing machine, the machinist or the persons who is operating, they need not to worry, because everything is being automized in the computer controlled systems, that is CNC machines, computer numerically controlled systems. What will happen? Everything will be made in the form of programming, and operator who is operating that program, you should be he'll just fed the program into the system, and the part is almost as developed as per the required as per the program. And in the additive manufacturing also, once if you perform the operating procedure, and if you fed into the system, you need not to worry about the product, because product is automatically developed. Okay, so I would like to say it reduces the human cost and even human error. And one more advantage of the CNC machining include, it will have a greater dimensional accuracy as well as many compatible materials, including wood, metals and plastics that can be easily measured in case of CNC manufacturing. When it comes to 3D printing versus CNC machining, especially in case of materials, okay, so far what I taught is a machining process. Now let's go for the material process. Here in the material part, both the 3D printing as well as CNC machining are compatible with a wide varieties of materials, including both plastics as well as materials. That is because the 3D printers are typically more efficient than the traditional machining. But when it comes to material part, both the machines utilizes the plastics as well as metals. When it comes to the additive manufacturing machine, we can go for plastics, polymers, metals, as well as even human tissues also we utilize there. When it comes to 3D printing, it is more focused on plastics. Overall, though there is a changing rapidly is better, and more affordable ways of 3D printing metals are being developed by manufacturers such as 3D System, Arcam, Desktop Metals, and Mark Forged. So, here. So are some of the materials that we are using in case of 3D printer. So here when it comes to the differences between or distinction between 3D printing and CNC machining are nothing but additive manufacturing and CNC machines. When it comes to machining part, the difference between 3D printing and CNC machining is that 3D printing is a form of additive manufacturing, while the CNC machining is a subtractive manufacturing. Where when it comes to machining, CNC machining starts both with a block of material called blank is used and cut away material to create the finished product. And to do the cutters and spinners, some of the tools like cutters, spinners are needed here. When it comes to the another advantage of CNC machines is that it includes a greater dimensional accuracy, which can be compatible. Okay, and when it comes to material, both the cases we are using plastics, metals, and polymers also we are using. But in the additive manufacturing, that is nothing but 3D printing. It is more, it is concentrating more on plastics. So not all the 3D printers can use the materials like 3D printers can manipulate different materials such as plastics, metals, and polymers. However, it is not all 3D printers can use polymers, plastics, and metals. Just it takes a separate machine for each material. And also the 3D printers cannot work with every material that traditional manufacturers use due to high melting point. And also the CNC machines is older than 3D printing and still has a stronger base for it in the manufacturing industry. Yeah, another difference in the materials is that the most commonly used plastics that is in the CNC, say these are the materials ABS, nylon, PA66 and polycarbonate, acrylic that is PMMA called, polypropylene that is PP we are using commonly in case of CNC machines. And also these metals used in CNC machining, CNC machines also utilized aluminum can be used to develop the prototyping models. In most of the companies they are using aluminum to develop prototyping products to create high quality prototypes in a variety of industries. Aluminum is recyclable. That is one greater advantage of aluminum material. It has a good protective qualities and also finish. It creates effective prototypes for machining because of its flexibility. Other commonly used metals include stainless steel, magnesium alloy, zinc alloy, titanium, brass, etc. used in case of CNC machines. And when it comes for 3D printing, 3D printing also they have utilizes ABS, that is acrylonitrate, butadiene styrene, and also PLA, polylactic acid, acid, nylon, etc. Some of the biocompatible resins also utilized, and also some of the 3D printers also allow for the printing of parts is sand, ceramic, and even living materials. That is in the 3D printing we can go for sand, that is in the construction technology they are using sand, 3D modeling and all, they are to develop the 3D model, so to get the layered manufacturing, so they utilize the ceramics and even living materials. Most of the common materials used in 3D printing include aluminum, stainless steel, titanium, and titanium. It is also worth noting that to 3D print metal are more expensive, and industrial machines are required. Some materials such as superalloys or flexible materials like TPU cannot be created with CNC, so that it must be used with 3D printing or rapid tooling technology. These are certain differences between the 3D printing, that is in case of machining of a process or in case of materials, etc. And next point I would like to highlight here is that the 3D printing versus traditional machining. In the 3D printing, that is CNC machining starts with a block material and shapes it with a rotating tool. Following the programs, it carves away excess until you have the finished product. When it comes to material usage in the CNC and 3D, as I told, metal alloys, woods, acrylic, modeling foam, thermoplastics, machining wax, etc. When it comes to production rate as well as in the speed, the CNC is a faster solution than 3D printing. So automated CNC machining can work around the clock as long as they are properly machined. That is another one. The 3D printed products also require work after they are all built, like post-processing operations. The products need to be washed, polished, sealed, painting, etc. Some of the operations, that the post-processing operations where 3D printing is needed. I would like to tell you a few more things. The versatility of machinery for CNC versus 3D. In the CNC machines, they have utilized fixtures, tools, and custom designed parts, whereas in the 3D printing technology, it is not required. Only thing is here 3D printers don't have such kind of options like using jigs, fixtures, and other things. Some of the differences between the CNC machine as well as 3D machining. When it comes to noise and mess produced by the CNC and 3D, so the difference with respect to the noise and mess, here the differences relate to the subtractive and additive methods is that CNC machining is more noisier and messier than 3D printing, because it uses a tool to cut away the material, which creates noise and lot of scrap metal for wood savings. That is in the CNC machines. Whereas in the additive manufacturing, it is not there. It is reduced. You can see the next step is that processing, how the CNC machines, how the manufacturing process, that is it will be converted into additive manufacturing. First thing is we have to develop a CAD model, next convert the CAD model into STL format, then this STL file is transferred to machine, then machine has to be set up as per the program, and then we'll have to build the part. After that we'll have to remove the part and post processing applications. So this is what these are the steps in the manufacturing of products in the additive manufacturing, that is 3D print. You can observe here from this you can observe. So here that is part values and parts that we are fed into the system, that is 3D modeling also fed into the system. You can observe here like this. Okay, so next thing is here step 1. The steps involved in the production of AM parts. These are the steps that we are using in the AM parts. First we'll have to convert the material into CAD model. First we'll have to develop the CAD model. Here all AM parts must start with a software model that fully describes the external geometry. This can involve the use of almost many professional CAD solid modeling software, but the output must be 3D solid or surface representation. That is here the generation of computer aided design model, the model of design here. The term in terms of process chain, the first step here of AM technology is 3D digital computer aided design, that is CAD design. We'll have to, the first step is CAD design. The first step is CAD design. The second step is here the STL format. The second step is STL format. First step is AM design. AM design means here AM technologies is 3D computer aided design models where the computerized products exist in a computer space and the values of its geometry, material and properties are stored in the digital form and are readily retrievable. That is the first step here. That is first step, we'll have to all AM parts must start with the software model that fully describes the external geometry. This can involve the use of almost any professional CAD modeling softwares that we are using. The next step here is reverse engineering equipment, that is laser scanning can also be used here to create the representation. Next step is to convert to STL model, that is conversion of CAD model into STL format or AM machine acceptable format. STL format or conversion to STL in such a way that the AM machine has to accept this. Okay, here nearly every machine accepts the STL file format, which has become the de facto standards, and nearly every CAD system can output such a file format. So here in the almost all AM technologies available today uses the STL format, that is stereolithographical format. So here in the STL format of a 3D CAD model captures all surfaces of the 3D model by means of stitching triangles of various sizes on its surfaces. The spatial locations of the varieties of each triangle and the vectors normally to change the triangle when combined. So these features allow AM pre-processing programs to determine the spatial location. So that has been observed in this, that is I have highlighted only the points here. Nearly every AM machine accepts the STL format. Every AM machine or even for that matter every machine accepts the STL format, that is stereolithographic format. Here which has become a de facto standard, that is nothing but de facto standard. It will be like finite element analysis, how we are going to divide the product into a number of squares, mesh form. Like that, here we are going to develop the triangular shape of thing, and we can locate the spatial location, that is what de facto standards, and nearly every CAD system can output such as a file format, which describes the external closed surfaces of the original CAD model and forms the basis for calculation of the slices. Next is third step here is transfer of AM model, transfer of AM model into STL format. Here the AM machine into STL file and STL file format is that the STL file describing the part must be transferred to the AM machine. So once if you convert the CAD model into STL format, then STL file just transfer to the AM machine. Here there may be some general manipulation of the file so that it is the it should be the correct size, position and orientation for building. So once if you transfer the STL file into AM machine, one should check for the general manipulation, such as general manipulation of the file, such as the correct dimensions. Next step is machine setup. So here all AM machine must be properly set up prior to the build process. So we'll have to plan before itself, that is before build the product. So we should check the machine. So we'll have to set up the machine. So such settings would relate to the build parameters like the material constraints, energy sources, layer thickness, timings, etc. So this is what fourth step here. Next is step 5, that is we'll have to build step. Here the part has to be built here, that is building the part is mainly an automated process and the machine can largely carry on without supervision. So once if you fed the STL file into the system, you need not to worry, because machine takes its do its job, because it is everything has been automated here. We don't require any supervision. Only the superficial monitoring of the machine needs to take care at that time, so that it can ensure the error should not take place. So like running out of the material power or software glitches, etc. Next step is removal. That means once the process is over, material has to be removed from the machine, AM machine. That is, once the process is completed, that is built, the parts must be removed. They require interaction with the machine, which may have safely interlocks to ensure. So just for example, you can take the operating temperatures are sufficiently low, or that there are no actively moving parts. When it comes to step 7, that is a post-processing operations, here the post-processing operations consists of removal of part from the machine, and also it requires additional cleaning, washing, etc. When it comes to applications, parts may now be, once the parts is ready to be used, they may also require additional treatment before they are acceptable for use. Say for example, they require trimming up, painting, texture and finish. Treatments may be laborious and lengthy if the finishing requirements are very demanding. Advantages of additive manufacturing system: it will have freedom to design, complexity for free, so you can change at any time, and potential elimination of tooling, lightweight design, elimination of production, or some of the things that is more related to AM machine. There are some of the advantages. When it comes to applications of additive manufacturing, is of course in the industries including automotive, aerospace, biomedical, consumer goods and many others. When it comes to classification of additive manufacturing, it is of 3 types, like liquid based, solid based and powder based. So this is one AM process, that is liquid based, powder based and solid based. The liquid based, some of the classification of liquid based AM system is that stereolithography, jetting system, direct light processing. When it comes to powder based, these are the powder based system. Of course the students might have studied these things in the non-traditional machining, non-destructive, non-traditional machining, and even powder metallurgy also. And solid based thing here, fused deposition modeling, sheets stacking technologies. One of the photopolymerization, which is also called as stereolithography, you can observe here. So this is one of the stereolithographic one. You can observe the sketch here, the powder material. So been placed, bed has been prepared, and laser jet has been allowed to fall on the thing. That is, heat is supplied to the powdered powder particle, so that it can, the layer by layer it just compresses. So photopolymerization and discrete particle system. This is what photopolymerization, that is stereolithography, is a liquid based process which builds parts directly from the CAD software, whereas discrete particles are normally powders that are generally graded into a relatively uniform particles and uniform particle size and shape of the narrow size distribution. So here the SLA stereolithographic apparatus is a low power laser to harden photosensitive resins and achieve polymerization. And also these are 3D CAD file here. 3D, this begins with a 3D CAD file. The file is digitally sliced into series of parallel horizontal processes, horizontal cross sections, which are then provided to the stereolithographic operators. In the discrete particle system, the finer the particles are, the better, but there will be problems if the dimensions get too small in terms of controlling the distribution and dispersion. In the photopolymerization, the laser then solidifies the next cross section. This process is repeated until the part. So this is what one type of this one powder bed fusion system, selective laser sintering, and a powder bed fusion system. You can observe this is a 2D view and 3D view. Like this here, powder has been placed, and this printing will be taking place. Powder bed fusion system here, laser sintering system here. You can observe the most prominent of the powder bed fusion process was originally developed at the University of Texas at Austin. Solid sheet system and the laminated system. Solid sheet system is one of the earliest AM technologies. It will have LOM also, that is laser laminated object manufacturing. This technology used a laser to cut the profiles, and layers were bonded together with a heat activated resin that was coated on one of the surface of the paper. This is what laminated object manufacturing is a process that combines additive and subtractive technology. So here the materials come in a sheet form and the layers are bonded together by pressure and heat application. Carbon dioxide laser cuts the material to the shape of each layer given the information of the 3D model. Thank you.